reactions include, first reaction is number 1, Wood's reaction. Wood's reaction. Okay. CH3Br reacts with Na. You have to take 2 atoms or 2 molecules of Na and Br CH3. That gives you CH3 plus 2 NaBr. Okay. Now see here, this is something. There is some peculiarity about this reaction. If you can prepare symmetric, you can prepare symmetric alkanes. Symmetric alkanes. You can prepare symmetric alkanes or alkanes with not symmetric alkanes. That is wrong. Alkanes with even number of carbons, even carbon atoms. Okay, that means you can prepare 2 carbon, 4 carbon, 6 carbon, etc. Suppose I want to prepare propane. Okay, if I want to prepare, if propane is to be prepared, can you think? Propane is to be prepared. Propane is needed. What should we do? Propane has got 3 carbons. So what we can do is we can take 2 alkyl halides. Look here, CH3Br. Then 2 molecules of Na plus, now see here, Br. Br CH2 CH3. Now you take this way. Okay. Now this sodium and 2 bromine. See, this bond will cut. This bond will break. And these 2 carbons will form a bond. This can prepare CH3, CH2, and CH3 plus 2 NaBr. Okay. This is possible, but there is one difficulty with this compound, with this. Suppose you take 100 molecules of this and 200 molecules of sodium atom and 100 molecules of this. Okay, now see, let me put it this way. So this is, I say this is compound number 1. And this is sodium, and this is compound number 2. Suppose you have 100, 1, 1, 1, 1, 1, 1, 1. Like this, there are 100 of them. Then 2, 2, 2, 2, 2, 2, 2, 2. And then you have sodium. Remember, it is randomly distributed. Okay, it is randomly distributed. So what 3 things can happen? One is, one CH3Br. Yeah, one is this reaction. Okay, one is this possible reaction. The second is you can have a CH3Br plus 2Na plus CH3Br. Two same molecules of this can combine and will give you CH3, CH3. So this is going to be an additional product. You get ethane. Similarly, ethyl bromide, two molecules can combine. Br C2H5 and can form 1, 2, 3, 4. What is this? Butane. See this? So how many products you will get in a single reaction itself? 3 products. So there are 3 products possible. And therefore, this reaction is not having, it cannot be used. Therefore, it cannot be used. Cannot be used to prepare even number, that is alkanes with even number of carbon. Alkanes, sorry, with odd number of carbon. With odd carbons. Clear? So that is this is what's reaction and its advantage and disadvantage. Okay. So advantage and disadvantage. So now there is an extension of this reaction which is called Wurtz-Fittig reaction. Wurtz-Fittig reaction. Wurtz-Fittig reaction. Very similar, but it is an aromatic compound. C6H5Br plus 2Na, 2Na, giving C6H5 plus CH3Br, CH3Br. You will get C6H5CH3 plus 2NABr. Now this will be an interesting reaction in the sense, yeah, we can argue the same way. What is the argument? Two molecules of this can combine. See here, one molecule of this plus 2Na plus a second molecule of this. This also can give this product, biphenyl. This is called biphenyl. Is it not possible? It is not possible because not possible. With sodium. Since, what is the reason? Look at the reason. The reason is this is an sp2 carbon because benzene contains sp2 sp3 bond, which is more difficult to break. More difficult to break then sp3 bond, sp3 bond in alkyl halide in CH3Br. See this. Now, how do you know whether this is sp2 or sp3? See, you have double bond here. I'll remove that. One second. I'll remove the circle. I'll remove up. Okay. Now, see here. You have 3 double bonds. Oh, what is this? One second. Yeah. Yes. See, you have 3 double bonds here. Okay. So when you have a double bond on a carbon, it will be sp2. When there is no double bond, it will be sp3. When you have a triple bond or 2 double bonds, it will be sp. So here, this bond is stronger. This bond is stronger than this bond. Okay. So it is not easily formed here. Now you will have a question. Why not in the same one? How can you avoid formation of this? This will be fast. This will be fast. So it can form ethene also. Okay. Okay. This also can be formed. Now here you have to develop an experimental technique. That's all. You have to develop an experiment. The experimental technique is always you keep this compound in excess. Okay. That is what you have to do is keep the alkyl halide always in excess. How will you do that? This can be done by what method? See, you have a reaction flask. You have a reaction flask. Remember, you put a sodium metal solvent, something like maybe ether or something, maybe a solvent used. And into that you add the complete amount of, and also this. They also you add C6H5Br. Now, using a small funnel, add alkyl halide, add CH3Br dropwise. So at any particular time, the amount of CH3Br is kept minimum so that it will go and catch only the benzyl bromide. So thereby you can reduce the amount of this one. Even though a small amount of this will be formed, both will be formed in very small amount. Okay, but you can minimize this by altering the reaction techniques. You keep see this is what is called process development. These are some of the ideas which you will get when you work in continuous in the laboratory to uh, make these reactions feasible. Okay, so industry does a lot of research and development work, process development work like this to increase the yield and purity of the compound. Okay, because for them it is money. Okay, so that is how you prepare. Now there is a different reaction. If suppose you want to prepare both aromatic compounds, you can use, if you want to prepare both aromatic compounds, I'll put the names here. So to prepare both aromatic compounds, you can do same reaction with 2Na plus yes. Okay. This will give. This also will give you the product. But remember, this is done at high temperature. You have to do this at high temperature. Maybe at a high temperature, if you do this, you will get bifilar. So it is all depending on the rate of reactivity. Okay, this reactivity is lower. This reactivity is a bit lower, so you can, depending on the substance you add, you can convert it into this word fatigue or fatigue reaction. So this reaction is known as fatigue reaction. Fatigue reaction. So Woods reaction, Woods fatigue reaction, and fatigue reaction. Fatigue reaction gives you aromatic compound. Woods reaction gives you aliphatic compound, aliphatic alkane, and the Woods fatigue will give you a mixture of these two. Okay. So these are the reactions of alkyl halides, reactions and synthesis of alkyl halides. Let us take next alcohols. Alcohols. Alcohols are compounds containing OH group. You can have primary alcohol, primary, example, yeah, anything which contains a CH2OH. So that way, methyl alcohol is also primary. I will say that. Actually, the real meaning of primary means it is having one CC bond. Primary indicates one CC bond. Secondary indicates two CC bond. And therefore, we always write methyl separately. Secondary means two CC bonds. And tertiary means three CC bonds. Tertiary alcohol. Okay. So these are the three primary, secondary, and tertiary. Remember, all of them have entirely different properties, chemical as well as physical. They have entirely different properties, and you can think of the general formula: CH3, CH2, OH. See, think about the general formula. What is the general formula? CNH 2n plus 2 O. Okay. So what does it mean? There is no change in the number of hydrogen atoms when an oxygen is added to an alkane. There is no change in the number of hydrogen atoms when there is an oxygen being added to an alkane. Say, for example, see here, CH3, CH3. You can simply add, you can break this and form CH3, O, CH3. Or you can break, see here, CH3, CH2, OH. See that? What you have done? What you have done? You have broken this and put an oxygen in the center. Overall molecular formula of number of hydrogen does not change. Or I can break a bond here. I make CH2 and H and break this bond. And then insert an oxygen. That is what I have done here. You get alcohol. Alcohol. This is called ether. So oxygen is divalent. Since oxygen is divalent, you can insert oxygen anywhere without affecting the number of hydrogen in the molecule. Okay, but think about the bromo compound. Just think about bromo compound. Write it here. Single bromo compound. CH3. I'll put CH2Br. CH2H. This is what? Ethane. If I want to convert this into, if I want to introduce a bromine, let me put it that way. If I want to introduce a bromine, I have to shoot this off. CH3, CH2, Br. So hydrogen takes a place of bromine. Okay, but here it is not like that. Here it is just getting added into it. This is because bromine is monovalent. Bromine is having one valence, but high oxygen is having two valences. Okay, so that is. Now let's look at the preparation of alcohols. Preparation. What are the different methods of preparation of alcohol? Now, one of the easiest method of making any of these three alcohol is by Grignard reaction. You must, I don't know whether you have remember this reaction. You have studied this in your +2. Yes. Oh. So, Grignard reaction. What is Grignard reaction? A very important reaction in industry. People do a lot of Grignard reaction in industry. It's very dangerous also. It is because it's using either a solvent. That's only thing. Otherwise, it's okay. It's a good reaction. You take an alkyl halide, R, X, and react with magnesium, Mg. You will get a compound, R, Mg, X. Remember, it is again divalent. That is why you can simply insert a magnesium inside. You can simply insert a magnesium. And now, this you react with formaldehyde, H, C, H, double bond, O. Okay, react with formaldehyde. Now, here I want you to recollect our bond breakage. We will just bond breaking. Let us see whether we can revise the bond breaking process here. Okay. Now, the question is, we want to break which bond has to be, when you break these bonds to form a new compound, in which direction these electrons will move. That is very important in bond breaking. So let us recollect. There are two types of bond breaking. Two types. I have taught this before, but it may be required. Two types. One is homolytic. Homolytic. Normally, this is occurring under H nu, photochemical condition. So you don't have to worry on the usual reactions. Only if you have H nu, you have to do homolytic bond fission. Now, what is homolytic bond fission? You have bonds between identical atoms. Okay, now this bond will go to this, and this electron will go to this. There are two electrons. One will go to this atom, other goes to other atom. So you get 2 A dot. Example for this reaction we have seen very common, Cl2 giving 2 Cl dot. This is the example for this. You have to write H nu here. Okay, another example is in presence of in presence of a free radical, in presence of a radical, a bond can break. Look here, I have got CH4. I write only one H here. CH3H, CH4. Now, if this is reacted with this, so in presence of one radical, a neutral molecule can break. Now see here, one comes here and one comes here. And see here, this forms a bond. Look at the way the electron is transferred. That is what you have to follow. This is what you have to follow. Okay, a half-headed arrow indicate one electron movement. See that. So what do you get? Just look at the arrow, what is happening. This electron. Remember, this bond indicates 2 electrons. One is here, one is here. So one electron is going to the CS3 and it is residing there. So you get a methyl radical. Methyl radical. Plus H radical will react with Cl radical to form HCl. So these are a homolytic bond fission. Okay. So homolytic bond fission will occur under 2 different conditions. Number 1, this in presence of HU, or even heat is possible, high temperature is required. And second one, in presence of other free radicals. Okay, so now let us look at the heterolytic bond fission. Heterolytic bond fission. That's the second type, which is very commonly used, which we commonly come across. Heterolytic bond fission. Heterolytic bond fission. Now, what is heterolytic bond fission? I have a bond between 2 atoms, A and B. The bond will break towards B. That means both the electrons will go to B. So I will rewrite this with 2 electrons. That also. Now, an arrow like this means both the electrons are moving towards B. So what will see, A has lost an electron, therefore it becomes positive. B has gained an electron, it becomes negative. See that. Actually, this electron belongs to A. This electron belongs to B. But now we get both the electrons, and therefore it attains a negative charge. Now, what is the condition? The condition is B should be more electronegative than A. In electronegativity. In electronegativity. Okay. So this is so B is more electronegative than A. And like this only. So this is what you have to consider. Whenever you want to break a bond, consider the electronegativity. Now let us come back to what we have done here. Look here. We have RH. We just formed the RMGX. Now we have to break this bond into 2. Okay. We have to see where to break this bond, RMG bond, and get attached to this double bonded molecule. First of all, let us see how will you break this. See here, Magnesium is a metal, and you have R means carbon compound. So let me put R as CH3. CH3. R. Mg. Let me put Br. Now see, this bond will break only in this direction. Why? Because metal is more electropositive than carbon. Any metal. Normally, most of the metals are more electropositive than carbon. Magnesium is more electropositive. So carbon is more electronegative. What will you get? You will get a carbanion. Remember, this is one of the rarest moments when you get a carbanion in organic chemistry. A very important, this is the importance of Grignard reaction. Very few reactions will generate carbanion. Most of the reactions are other reactions are ammonium ions or carbocations. So this is one of the rare reactions in which carbanion is formed. Now this carbanion will act as a nucleophile here. This is your formaldehyde. This is a formaldehyde. Okay. Now where will this carbanion react? Where will it react? It will react at an electron deficient center. Now you know this is delta positive. This is delta negative. Why? Why? Inductive effect. By inductive effect. By inductive. What is inductive effect? At least in this case, what is inductive effect? This is inductive effect. Look here.